In this video, we're going to find pi and then write a Python code. So the terminology we're using here is to use the rectangles to find a quarter of a unit circle. We know the pi is equals to the area of a unit circle. So finally, we're going to times 4. So here, how do we find the area of a rectangle? Is by width times height, and that's the area of rectangle. And then we know the width is always going to be the same because we're using the same amount of, that depends on the numbers of rectangles we're using. So it's always going to be 1 over n. So here we're using 4 rectangles, so that's going to be 1 over n, which is 4. Now to find height is a little bit tricky because we're trying to find the midpoint height. Not here. Not here. Not here. We're trying to find the midpoint between this and this. So in the midpoint right here, it's the most accurate because you see it's less difference here versus if we're going over here, that's gonna be a lot more than the value it should be. So how do we find the height on the midpoint? With that, we're going to use a triangle. So you see I draw a triangle here. So the width for this triangle here is 3 over 8. And then this length is always going to be 1 because this is a unit circle. So for each rectangles, we connect to the vertex. That's going to be 1. So we know the width. So for this height, we know this length and this length. We can know this part. So first of all, we need to define all the width. So for this triangle here, to find this height, we're only using the this width to find the height for this rectangle, and then we're going to multiply by 1 over n, which is this rectangle, and then we find this rectangle's width area. So that's the idea. And then how do we find the width for all the midpoints? Is right here. So you can see for the first one is right here. It's only 1 over 8. And then for the next triangle, so it's going to be 1 over 4 plus another 1 over 8. For the next one is going to be 1 over 2, this length, equal plus another 1 over 8, and so on. And according to this, we wrote a function. So 8 is always going to be 2n, right? So that's the numbers of rectangles we're using. That plus 2 because we're finding the midpoint of them, and then plus 2n again, and then here's 2 times I, that's whichever rectangles we're using. So when I equals to 0, there's no value in here, so that's gonna be just 1/8. And when I is equals to 1, this is 2n, and then plus 2 times I, that's 2/8, give me this number, and so on. And then we see those results are the same as those results, so we know the function is working. Now we're trying to find, using this, trying to find the height of each rectangle. We know from a right triangle terminology, this is how we find the y value, which is the height. And then we're using this, the midpoint x, that's what I call it. It's the new value of the width, which is the vertex to the midpoint of each rectangle. And then we replace that into this here. So here's the function for finding height. And then rectangles equals to width times height, which gives us this function. And then we know how to write our code for finding pi. So in my code, I have 3 functions. First, I import math, of course, and then I have finding pi function, finding n function, and then the main function here. Those 2 are the helper functions, and then we're going to call them right here. So here is my code for finding the pi. First, we need to define I equals to 0. So it knows where to start from. And then we know the value of n width is always equals to 1/n. And then here we're trying to find midpoint x, which is the new width we're using to find the height. And then here is the height function we wrote in the Python code. And then rectangles equals to height times width. And then here I use a sum accumulator to find the sum of all the rectangles. We add them all together and then times 4. That gives us the value of pi. And then I return it so later we can use it. And then the next function is finding n. So this is the arrow, pi, which is this here. We call this function right here +1. So because for the for loop it always go less than 1, so we add 1. And then the arrow is equals to the estimated pi minus real pi value, and then divided by real value pi again, and then times 100, round it to 5. That will give us the arrow percentage. And then when this arrow percentage is less or equals to 0.001, it's gonna return the value of n. So that will give us the smallest value of n when the arrow is less or equal to this 0.001. and then we write our main function. This is just the introduction, and there's the label. And then in this for loop, I'm using the list. So this loop is going to run 4 times. Each time n is going to equal to 2 to 20 to 2000 and 2 million. And then we call pi again and the arrow again in this function. And then we're going to print everything here labeled. The values of the numbers of rectangles we're using, the value of pi using this number of rectangles, and the real the other way around. This is the estimated pi, and then this is the real value. And then here's the percentage of error. And then here we're using this result here. We call that function again. So that's the value of n right here. That's going to give us the smallest n when it's less or equals to this percentage of error. And here's the code. And then we're going to run it. And there it is. The smallest n is going to be 491. Oops. There it is.